a little bit of a different kind of talk. I really wanted to, after I got done with this workflow, I was like, wow, that was kind of a lot. And, I thought I'd just share this, it's just like a view from the trenches, because I'm a user, really. I'm not a developer. And so I encountered a number of like stumbles. So I thought I'd sort of share, like, I should call them challenges, and how I, dealt with those challenges. And so, my goal is actually, just to share that this stuff can be hard. And, when somebody gives a demo, often it just works perfectly, but then you go try it for yourself on some other data set and you encounter problems typically. And so, don't feel like you're alone. Everybody has these problems unless they're very lucky. And so I hope you'll see something in the approaches that I took that you'll find useful in your own work. And maybe I'll find a better way of doing things myself, thanks to all the stellar folks on the call here.
Rich, do you want to full screen this just for the sake of
yeah, I'm in the, yeah, okay. Let me shrink down this guy and go to, about that. That's the way I always like practice these, so anyway, so yeah, well, wait a minute, like, didn't Peter Marsh already talk about ERA5? Like, what are you doing, Rich? And the answer is that I thought so too, but I went and looked at, the ERA5 variables, and the folks, the hydrologic modeling folks at USGS who I was working with, they wanted the soil moisture, snow depth, and a bunch of other stuff. Turns out that's ERA5 land data, and that doesn't exist on AWS or Planetary Computer. So, okay, so what do you do about that? Like, if you wanted to make it cloud optimized, put it on the cloud, what would you do? And so, this is what I did. I want to use the same tools we always use, Dask, Xarray, FSpec, intake, so on to create this. What did I do? So at this point, I'm going to, well, okay, so the plan is, I'm going to construct it. You have to request these data with it using an API. The API delivers back in that CDF file. So I'm going to construct an API request that gets back in that CDF file. And we know from experience that if we have chunks in this .cdf file, about 100 megabytes, that'll work pretty well on the cloud. And so my plan was to issue a bunch of API requests in parallel using Dask, get a collection of .cdf files, and then Kerchunk that collection into a single virtual cloud optimized data set. And then, explore it, make sure it looks good, test it out. So let's jump into the demo. So there's a series of notebooks here, and there's a repo that you can get these from, and some rendered notebook links here in the talk if you want to go just check them out. So that this link that I hit actually will work for anybody who's on the ESIP Q-Hub, but it won't work. It'll come up with a 404 if you're if you're not on the ESIP Q-Hub. So basically, I have this collection of notebooks. Actually, it landed me. That's interesting. It landed me right in one of these. Okay, here, let me go to my. Oh, I guess things are slow. Hold on, I have to wait for my file browser to load. It looks like. There we go. Okay, so this is the first notebook. Actually, let me just clear this stuff and go up here and, wow, everything, okay, everything's super slow. Low system resources. Yipes, okay. Let me go clear the, let me close these tabs and close everything down here. Start fresh. All right. Oops, now I got dropped out of my. All right, here's all the users. Wandering back here to my repo. Last modified Pangea showcase. Okay. Sort these again. All right, so the first thing I did was I wanted to check out the, just test out the API, right? Make sure that my syntax was correct and all that. So, you can go visit this web page. It'll show you how to construct a query. And then you need this package in the C, and let me go up one font size here. CDS API. And so the first thing you do is you have to create a client object, and this actually relies on a token being stored, a username and token being stored in this CDS API location. Okay, so that's first step. You got to sign up, get your token, and then you're good to go. You can look over the list of variables, and just for I'm just showing these two variables that I picked. Snow depth equivalent, there's a table there on the link at the top that you can go look on. I'll find all the variables that you can request. So I'm just going to request the continental US since that's what the folks were interested in. And I'm going to skip actually down to here for just a second to the actual request. Okay. All right, so the actual request looks like this. You have this object, and you say retrieve, you give it some name, and you give it a variable list, and then you can specify the area, the date, and then so actually this is the way you specify a date range, and then you specify all the hours. So, and then the output type is netcdf. The important thing here was to realize in advance that my goal was to aggregate all these netcdf files, so I had to pick, not like the examples show you downloading a month, and a month would have been okay, except that it would have been more difficult than because these files need to be aggregated. They need to all have chunks that are whole chunks. And so I issued this request. I'm going to skip the stuff above, and you can just see, it's creating this request. It gives you some information, downloads this netcdf file. And we open it up and we take a look at it. Looks kind of normal. CF convention's good. And then, if we take a look at one of the variables, it looks normal, float 32 and so forth. And we plot it up. Okay, it looks like snow depth, everything good. Then we take a look at the encoding. And we find out that actually, this was actually stored as int16 with a scale factor and add offset. Turns out this is what they're delivering is netcdf3 files with a scale factor and add offset. So you basically have one chunk per file, and it's using scale factor and add offset. That's not going to work with Kerchunk because the scale factor and add offset are changing here with every file that you download. So they're calculated by the API and stuffed into the file, and that's that's not going to work because a single data set only has one scale factor and add offset in the netcdf data model. I hope that makes sense. So I was like, okay, well, I guess I still want netcdf files. So all right, well, I'll just throw in a something that will convert to netcdf4, and because it's already compressed, I want some kind of compression. So yeah, why not try out Xbitinfo? And so I tested out actually running Xbitinfo, and next week's showcase talk is actually on Xbitinfo, so I'm not going to dive into this too much. But basically, you can open up a data set, check it out, specify that you want to keep like 99% of the real information, and it will tell you then how many bits to keep in the different variables. So then you can just, in this case, I'm saving this to a little file, this little very simple little data set that just has a couple of values in it. And here I'm actually applying this bit rounding to the data set, to the netcdf3 file, and then outputting a netcdf4 file. And if I look at the difference between the two files, I can see that actually just saving 99% of the information according to Xbitinfo actually gives us more than a factor of 3 improvement over the scale factor add offset netcdf3 file. So I was happy with that, and so then let's proceed onward. So I thought, okay, now I've got my little function that's going to download a file, then compress it using Xbitinfo and storing it. So I've got basically the same stuff here. I'm going to skip over this stuff. And here's my little function I'm going to call get chunk. And it's going to take an S3 file name and this keep bits variable. And I'm just going to call that on a bunch of different S3 files that have the date strings in them. So maybe a little bit backwards, but I'm going to give a construct S3 file names that have dates in them and then pass them to this routine. And this is going to then call the API query. So this get chunk routine will get a chunk and store it as a compressed data. And actually, this is something for the future, but I didn't really want to import Xbitinfo with I don't need the Julia stuff in this notebook. The Julia stuff is what calculates the Xbitinfo, and it's actually kind of a really heavy lift, and it takes a long time to load. So I just stripped the stuff I needed out of Xbitinfo. So there's probably a better way to do that. So I just stuffed that in here, and here's my same query, blah blah blah, and the only thing here is that so these are actually going to be submitted to a Dask gateway cluster. So it actually writes the netcdf file. Right? I couldn't do anything about how it gives me the file, right? So it gives me the file, writes it to local disk. Okay, so that's on some container, running as a Dask worker. So then I just upload, to the cloud. So I have it on object storage and then remove that local file. So that's all part of this function I call. So I have this little routine to configure a cluster. Let's not worry too much about that. So I have a cluster running, and I load my keep bits that I've saved, and I go ahead and do this Dask delayed get chunk, giving it S3 file and keep bits for S3 file in all the S3 files that I want. And then actually in this case, I just did 20 of them just to show how long it takes. I did some experimentation, and it turns out like 10 workers is pretty good. Like if you do one worker, it takes about 10 times as long, but if you do 20 workers, it only is like 20% faster. So, so one worker would do this job in an hour. 5 workers did the job in like 15 minutes, 10 workers in like a little bit less than, in 6 minutes. So, and so if you calculate how long this whole thing takes to complete, it takes 6 hours. And in fact, that's about how long it took. But along the way, I got kicked out by the API because I had too many requests in 24 hours. So I wrote this thing so that it would actually, if we scroll back up to the top, I wrote this so that it would actually look for the files that are already there. And basically, see what files are already there, see what files I have yet to create, and then just process those. So in this case, I had those 20 already done. So, I had 1,074 to do, originally, and now I only have 1054. So I can just rerun this script, right? And it'll just process the ones that are left if I get kicked out for some reason. And it's typical of these APIs. There's some kind of, they don't scale that well. Typically, of course, depends. Maybe they have it on Lambda and it scales beautifully or something or whatever, something like that. But in this case, it's running on some server somewhere, and then they have other limits, like how many you can do in 24 hours and stuff like that. All right, well, that all works. So, took 6 hours. And so now I have a pile of netcdf files. And so now I head into Kerchunk land. So this third notebook is basically from Kerchunk. We use these 2 functions, one that just takes a netcdf file and converts it to a single JSON file. And then this one here that actually takes the multiple JSONs and converts it into a single combined JSON for the entire collection. So again, I think I'm not going to dwell on this too much in the interest of time. I actually do the same thing. I look at all the netcdf files, and I see if we have, JSON files that are already been created, and then just, process the ones that are left. And I'm just going to skip down here to the kind of key function here. Again, I have a single function, generate JSON, that just takes the file name on input. It creates this JSON file and then dumps it out to S3. And so like, here's an example output, this thing gets created like this JSON. And so then again, I create the cluster, and now because I decided just to use Dask bag instead, just to kind of show how you can use Dask bag in a similar way. You have your function, generate JSON. It takes inputs from a list, in this case, this F list. So you can, and then in this case, you can say, I have 30 workers. I'm going to give it 30 partitions. Go ahead and compute this thing. And it basically does the same thing as this Dask compute. It just goes through a long list of delayed functions and calculates them on your workers. So at the end, we do a multi-zar to zar. Takes about 2 minutes. And then let's just go skipping to the final result, which is like this little Explorer notebook, which is going to take a look. And this one I'll actually run. I didn't want to run the other ones in the interest of time, but you know, they don't, with the exception of the 6-hour one, the other ones don't take too long. So you could test them out for yourself, assuming you have the API key and of course the environment. So let's see here, waiting for this guy to, oh, I guess I must have the rendered output and everything in here. Okay, let's clear the output. So here we're just going to use fspec, Xarray, and hvplot. I'm going to turn off warnings because hvplot is spewing a bunch of warnings about nans that are annoying. I'm just going to load, I'm going to point at this JSON that we created. I'm going to open it up with fspec as a reference file system. And I just want to show that if we list that file system, it looks just like a Xarray data set. Then we can do a mapper and open that guy up. And now we see the full latitude, longitude, and 360,000 time steps. And we've got our 2 variables, snow depth and soil moisture. We can take a look at one of these guys. Let's give myself a little more real estate here, just to make sure that it looks decent. This is actually a latitude longitude grid, so I don't need to use quad mesh. I can use geo, and geo equals true, and tiles equals Esri to put a tile service on it. You get this nice little map here of snow depth on a particular date with a time slider over here. And if we just like drag to some random spot, you can see, if I guess actually a time slider, I'm not sure whether it like tries to render every time you kind of stopped, but hopefully it will, it might be cycling through those steps actually. Let's skip down here to actually doing a selection. So if we take a look at one of the like snow depth, you can see that actually these things, this is like 68 megabytes. It's 68 megabytes actually because I skipped over something. I should have done this. Actually, when I load this data set here, I'm loading it with chunks equals time that's like 10 times bigger than the original chunk size. And that's because I didn't realize when I wrote the netcdf4 file that it actually was breaking it, because I didn't specify the chunking again. This is sort of one of these annoying Xarray kind of things that, well, I don't know. No, it's a netcdf library thing. Actually, it'll pick some chunking scheme for you if you don't specify the chunking. And so it actually broke this into pieces. So if I showed like, actually, if I show, let me just add a cell here and show you. Actually, if we don't do, well, actually, it doesn't matter. You can see that it's actually not the full, it's not the full domain anymore, like what used to be in the netcdf3 file. It was one big chunk, and now it's 83 by 193. That's just a weird, a thing that netcdf library did. So I was thinking about, well, changing that, and I was like, well, actually, that's not too bad. I'll just make this, I'll just make these chunks bigger in time when I read them in, and they, they're still somewhat reasonably sized. And Martin's actually done some work to make smaller chunks work better. So this thing works actually pretty well. So let's see. Let's go down here and do the selection. So I want to select a time period. And I'm going to select like for a particular latitude and longitude. So I'm going to actually pull a time series for 2 years from this one location. And this is going to read 1,020 chunks. So I'm going to load it and then plot it. And even though I don't even have a Dask cluster here, this thing is pretty loads pretty quickly. So 11 seconds just on a single core. And there's my nice time series where we're actually looking at the snow depth in A basin. So this is when I went skiing at A basin in 1995. So I thought I'd check that out. And so it's pretty speedy to do plots, maps, and it's pretty speedy to do time series. And we can of course improve the user experience by making a little intake catalog so that all the user has to do is get the data set by going to Dask, and you hide all the stuff about the chunking and everything in the intake file. If we want to improve the user experience for plotting, I'm just going to blast through these guys here to this little dashboard using panel. And what I did here was I just put this date time picker in here, because with a data set this size, it's really kind of annoying to have that slider, as we saw earlier. And you can't really put them on a selection widget either. You don't really want to type in, because people might type something in wrong, that didn't work. And so a date time picker is really what you want. Panel has one. So in this case, I've got a little thing with a widget to select a base map. I select the variables. This could be a longer list, of course. And then I have this little date time over here where if I click here, it comes up with this nice little browser, and I can go like some other date. If you click, then you can see the time changes here. And, hopefully the plot changes. Or maybe I should have, there it goes, yeah. And then, of course, we can zoom in and, it'll update the plot and all that good stuff that we turn on the hover and see what we got. So that's it. I think I've got these notebooks rendered here. These are issues that often get encountered, like APIs have this limited ability to scale, may have some other problems, like they're going to kick you out. The gateway, I didn't really cover this exactly, but I see a lot of problems where people are like, what happened? I get killed worker, and it's because the gateway workers don't have credentials. They need the credentials to access requester pays. They need the credentials to access APIs. And another problem is that the workers don't see the local file system. I actually struggled for a while because I had my keep bits. I had my data set loaded from the keep bits netcdf file, but I didn't do the .load. And so when I went and looked at the worker logs, it was saying he couldn't find this, keep bits.nc file. And I was like, what? Why is it trying to find that? It was because, I didn't load it. And so everything was lazy, right? So it's still the workers were trying to find it. They couldn't find it. You can't use Kerchunk to aggregate netcdf files that have partial chunks. You can't use Kerchunk to aggregate netcdf files that have scale factor and add offset. So, but these things are all, can be overcome, and the result is a pretty awesome data set. And may not be the most beautiful workflow in the world, but it does work. So I'll call it there. Thanks a lot.
Thanks so much, Rich.
Jim,
That was
love Jim's comment. There's always a dig against the old turbo color map.
Yeah. All right. So really great talk, Rich. It was awesome to hear such a real workflow and the different challenge. Quick show of hands, like who on the call has downloaded data from ECMWF through the CDF's API? Just give a little hands up if you've. All right, I'm seeing at least 5, 6. Yeah. A lot of people, okay, yeah. So definitely something of very broad interest. So let's open this up to questions. Put your hand down for that. Now raise your hand if you want to ask Rich a question.